Hi, my name is Eric Rupzoff, and I am in the Monday 10 a.m. lab section for ECE 102. I will be demoing the Nano processor. This is lab 12. It contains 9 different instruction sets that perform functions between a register bank, an accumulator, and a multiplication and an adder subtractor unit. These controls These functions are controlled by TSBAs that are enabled based on the instructions I give to the control realm. The rest of the details of how my circuit works can be found in my memorandum, but I will begin demoing the circuit. So before I do, I just want to say that this is the clock pulse for my register and my accumulator. The ROMs run on a fast clock. This is the clear for my register bank, and this is the clear for my accumulator. And to begin, I will do the in function. And my instruction code goes from 0 to 8, so I'll be using those values to demonstrate. So I want to input 1 into register 1. I will put 1 as the input value, 8 as the instruction code, and then these are my registers, 1, 2, and then 3 when they're both up. I want to input that in register 1, and then to output it, the instruction code is 7, so I'll bring this down, and then I will want to output the contents of register 1. See, that's 0, 1, 1, 1, 7. And now I want to do that for register 2 and 3, so I'll go through that relatively quickly. So 2 in register 2, I want to input it, press the clock pulse, bring that down, and then I want to output the contents, so that's 2 in register 2, and then register 3, I want to store register 3, or the number 3 in register 3, and then I want to output the contents of register 3, which is 3. Now for my next command, I'm going to do into the accumulator. Now with this Nano processor, you can input values directly into the accumulator, where the arithmetic units take values from. And so I'm going to do that. The instruction code to input into the accumulator is 6. So that's 6, and then I want to input the value 2. I'll do 2. And then and then I'll put that in. And then I want to output the contents of the accumulator, I can show that 2 is in there. And to do that, it is 5. So 5, so that's 2 in the accumulator. And now I want to add. So I want to add the contents of register 1, which is the value 1, to the accumulator. So I open up register 1, and then I give the add instruction, which is the number 4. So here's the add instruction, and I add that, and then I want to output the contents of the accumulator because I just added 1 to 2, and it should be 3, and it is. And now I want to do a subtraction. So in the accumulator now I have the number 3. So I want to subtract the contents of it. So the instruction code for that is 3, and I will subtract what's in register 1, which is 1. And I'll subtract 3. So subtract, and I will do that function, and then I will output what's in the accumulator, and it should be 2. So accumulator there, 2. There we go. And now I want to do a multiplication. So I'm going to just do 2 times 2, which is 4. So I will activate the multiplication code, which is 2, and then I can either do it through the input values, or I can do it from the register bank, but I'll do 2 times 3. And then I'll do the clock function and I'll output the contents of the accumulator, which is going to be 6. So 3 times 2 is 6. And now I have the move function, which moves the contents of the register bank into the accumulator. But before that, I want to do the move accumulator function that moves from the accumulator into the register bank. To do that, the instruction code is 0, so none of these switches are on. And I want to move the value 6 into register 1, and I'll do that. And then I will output register 1 to show that it has been moved to register 1. And now I want to move the contents of register 3 into the accumulator, so I'm going to use the move function, which is 1. Input that. I do this. And now I want to show what's in the accumulator. So again, the instruction is 5. Do that. And that's 3. The value 3 was in register 3, and now it's in the accumulator. Yep, that's my nano processor. Those are the 9 different functions demonstrated. Let me just show the clear real quick. I'll just do this, clear it out, and now I'll just show that. See, 0 in the accumulator and 0 in the register bank. So it's all cleared. All right, thank you.